Welcome back to a new video. This lecture is going to be about decomposition. This video is going to be one of the videos that I create for my time series analysis playlist. You can just reach to that playlist from the cards of this video. Let's start coding. Let's create our dataset. As I said in our first lecture of this course, I will do copy paste for data creation from now on. So I'm just going to make paste, and then I'm going to say data frame is going to be equal to the pandas data frame, and I will say data. So after that we can see our data set using data frame.head with displaying the first 5 rows. Great, we have date, values, column 1, 2 and 3. So this column count and the values can change from lecture to lecture. I'm going to try to make them different, but we are going to have date and values for all data sets we are going to have. So in this lecture we will apply time series decomposition to break down our dataset into 3 main components: trend, seasonal, and residual. This technique helps us understand the underlying patterns in time series data. We will use Python's time series decomposition tools to break down our data into its components. So I'm going to say from stats models time series analysis.seasonal import seasonal decompose, and then I'm going to say result, and I will say seasonal decompose data frame values, this column right here, and then I'm going to say model, and I will say additive, and I'm going to give a period value like 10, and then after creating this I will just call the result, and from this we can just access the trend, or we can just access to seasonal, or we can just access to residual like this. Residual will be resid for like this, and great. So now I'm going to talk about them one by one. Using the seasonal decompose function from the stats models library, we decompose the values column of our dataset. The model additive parameter specifies on additive decomposition, and we set the period parameter to 10 for seasonality. Now let's dive into the results and understand what each component represents. So let's start with trend. So I will say trend, and I will say result.trend. So the trend component captures the long-term direction or overall movement in the time series data. It represents the underlying continuous progression that may indicate growth, decline, or stability over time. In our tutorial, we use the trend component to extract the linear trend in the values column. Analyzing the trend provides insights into the general behavior of the time series data, helping to identify upward or downward trends and potential turning points. Okay, let's talk about seasonal component. So I'm going to set seasonal, and it's going to be result.seasonal like this. So the seasonal component represents recurring patterns or cycles within the data that repeat at regular intervals. These patterns could be daily, weekly, monthly, or any other fixed period. In our case, the seasonal decompose function detects and isolates the seasonal variations in the values column. Understanding the seasonal component helps us identify periodic trends such as daily sales fluctuations or monthly temperature variations. Okay, let's talk about residual component lastly. So I'm going to set something like residual, and it's going to be result.residual like this. So the residual component, also known as the remainder or error term, accounts for the unexplained variance in the time series data after removing the seasonal and trend components. It represents the random fluctuations or noise that remains in the data. Examining the residual component helps us understand whether the decomposition effectively captured the underlying patterns. A low amplitude residual typically indicates a successful decomposition, while a high amplitude residual may suggest additional complexity or irregularities in the data. So let's visualize these components. I will say import matplotlib.pyplot as plt again. We already did this in the data creation part, but I'm going to do this again. It's going to be matplotlib, and then after that I will say something like plt dot Actually, let's start by setting a figure size. Figure, and we will set figure size like, let's say 40 into 10. And then I'm going to say plt.subplot, and it's going to be, let's say something like 411, and I will say plt.plot. I will take the data frame values, and I'm going to give this a label like original. And I will give plt.legend like this. After that, I'm going to say plt.subplot 412, and I will say plt.plot trend, and I'm going to set the label as trend. And again, I'm going to say plt.legend like this, and I'm going to say plt.subplot 413 plt.plot seasonal, and label is going to be seasonal. I will say plt.legend at the end, and at the last step I will do the same operation again for the residual. I will say plt.plot, I will say residual, and label is going to be residual, and I will say plt.legend. At the end, I'm going to say something like tight layout like this, and I will say plt.show. So here is our plot. Looking pretty nice, right? So we created each of these plots using the subplots from matplotlib, and here we have original, trend, seasonal, and residual. Great. So for understanding the decomposition better, we just visualize the original time series along with its trend, seasonal, and residual components. Great. So at the top side, we can see the original, and we can see its components trend, seasonal, and residual at the lower sides. Great. Thanks for watching the video. I'm sharing 2 or 3 new videos every week about data science and Python programming. You can subscribe to my channel for more videos like this. This was one of the lectures of time series analysis playlist. You can watch the others for learning more. I'm going to add the playlist link in the cards of this video or in the description. See you in the next tutorial.